Hello, friends. So, welcome, and welcome. Yes, in this module, uh, this is all about numbers. This is the first video in the series of numbers. Yeah. So, in this video, we'll be going to discuss about all the names, all types of numbers. So, you can also call it as like the vocabulary of math. These words form the vocabulary of math. There are many questions wherein you see the word like natural numbers, integers, rational, irrational, real, imaginary, all these kind of names, right? Prime, composite, co-prime, and so on. So let's get to know everything about these types of numbers. You should be fully confident about these numbers after this video. All right. So first we'll be learning the tree classification of the numbers, then conversion of recurring into fractions, even odd operations. Okay, cool. Let's start. Okay. So when I tell you to tell me a number, these are some like natural common numbers which will click first, like 1, 2, 3, 4, 5, and so on. So these numbers came for the first time in the nature, hence the name natural. Notation N. Okay. Then if I include 0 in this, yes, whole numbers, right? Cool. Then if we, this is notation is W. Then if we include these negative numbers, same as natural but with negative sign. So whole numbers plus negatives forms integer. So what's the summary? What's the meaning of integers? Just remember three magical words. Numbers without decimal. All right. Numbers without decimal. Yes. I. This number, yes, this is not integer, right? So in integers, if I add fractions, then we get something called as rational numbers. Q. The notation is Q. Okay. What about these? If I include these numbers also, that pi, root 2, their answer, their exact answer you can't write because their answer is of the type non-recurring and non-terminating decimals. Okay. And rational, on the other hand, is either recurring or terminating decimals. So any number which you can express in the P by Q form. P by Q form means there's some numerator, there is some denominator. So ratio of two integers. So whichever number you can write in the form of ratio of two integers, they are called as rational numbers. And if you can't write it, it's simply opposite, irrational. Also, this rational irrational word is like a normal common word, English language word. Rational means something like which is something sensible. And nonsense is irrational. So irrational is like actually nonsense numbers. Rational is all sensible numbers. Okay. So now in rational, if I add irrational, we get real numbers. At least whatever it is, even if it is nonsense, it still exists. No. Yeah. So they are real numbers, R. And in this, if I include these kind of numbers, I, 3 plus 4, imaginary numbers. Yeah. Then we get complex numbers, C. This is the flow, friends. Let's understand each of them in greater detail. So complex number in that, first of all, something about I. I is an imaginary number. So basically, what is I? The value of I is square root of -1. Correct? Yes, iota or imaginary number. Let's explore the powers of I. I to the power 1 is I, right? I square is -1. I into I. I cube is I square into I. So -1 into I, so minus I, and I to the power 4 is ultimately -1 square is 1. I raised to 5 will again give me 1 into I, that is I only. I raised to 6 -1, I raised to 7 minus I raised to 8 is 1. Did you see all these four numbers in the same sequence got repeated? Yes. So the i's pattern of the powers of I is I -1 minus I 1. I -1 minus I and 1. So the value of the values of the powers of the I repeats after every 4 powers. We can also call it as a cyclicity. It's a cycle. I -1 minus I 1, then I again. So how to find such bigger power values? Yes, as you know, the cycle repeats after 4 powers, so take advantage of this fact. Divide the power by 4 and check remainder. I'm not interested in quotient. I'll get two things, quotient and remainder, but my interest is remainder. And also in some time you'll learn the divisibility test of 4. No need to divide this entire number by 4. Just divide the last 2-digit number, that is 47, by 4. So remainder is 3. Remainder 1 means I, remainder 2 means -1, remainder 3 means minus I. Alright, and remainder 0 will be 1. Answer is will be 1. Okay, so similarly, come on, I to the power 93. Yes, divide by 4. Remainder is 1. Remainder is 1. 1 means first value. Come on, 202. Yes, remainder is 2. So -1. 111. Divide by 4. Remainder, yeah, remainder 3 minus I, and so on. Cool. You know, this kind of number, this is a real number, this is imaginary number. If we write them like this is called as complex number. It contains two parts, the real number part and imaginary number part. Actually, what number goes well with this? Yeah, something like 5 minus 3i, which we call it as its conjugate. So here we saw that sign of the imaginary number got changed. Okay, real number was not disturbed. So we can add, subtract, multiply, divide easily. For example, if I add these two, a given complex number and its conjugates, so you can see 3i will get cancelled, so ultimately 10. If I multiply them, a square minus b square, how we got 34? A square minus b square. So 25 minus 9i square is -1. So ultimately 25 plus 9, isn't it? That is how we got 34. Yeah. You know, these terms you will see in quadratic equations when you solve that using that big formula minus b plus or minus root of b square minus 4ac upon 2a. So there you'll encounter these numbers. So you should be comfortable. So now we have done it here. So I hope you understood complex numbers, mainly imaginary numbers. This much knowledge is enough. Yeah, don't worry about more about this. Chalo. Next in the sequence is rational and irrational. So yeah, so a rational number is defined as any number of the form p by q, as we discussed some time back. Of course, p and q are integers and q cannot be 0. So ultimately ratio of two integers. Yeah. All right. Fractions were invented basically to solve the problem of division of integers. And another word for fraction is what? Ratio, right? So this is a ratio of p and q, or this is fraction p by q. Both are one and the same things. Okay. So a rational number is essentially a ratio of integers. That is what I said just now. Okay. All right. So how do we check it practically? Let's see. A decimal number is rational if it is either terminating something like this. You can easily write it as a ratio of two integers. See this, correct? Or it is recurring. Recurring means something like this. A particular pattern repeats continuously. So another word for recurring is repeating. Okay. We write it as 0.3 bar in short form. 3 के ऊपर bar है. We read it as bar. Simple. It is inspired by Hindi. वो 3 आता है बार बार. 3 बार बार आता है. Hence 0.3 bar. Okay. Sometimes something can be inspired by Hindi. Yes. And if you convert this into fraction, it is 1 by 3. We will soon learn how do we convert this recurring kind of decimal into fraction. Okay. Yeah. Let's see. For example, 0.34 bar. So 0.343434. So how many digits are repeating? 2, right? So I'll multiply by 100. That is second power of 2. Why? You'll understand. So let's assume this as x, 0.343434 repeating, right? If I multiply by 100, of course, decimal will shift to the right by 2 places, as you saw, 34.343434. Now you will understand why we multiplied by 100. If I subtract it now, subtract, come on, 100x minus x, yes, 99x. The decimal part gets cancelled. So ultimately I have 34, isn't it? X is 34 over 99. So I wanted to have the answer as integer. That is why we adjusted decimal in such a way that decimal part gets cancelled. That's the reason we multiplied by 100, friends. Okay, cool. Let's try a few more. 0.457. So I'll multiply by 1000 and subtract, right? So ultimately you'll get this. Now one unique pattern you will see now, some friends. So whenever there is a recurring decimal, in the denominator there is a lot of nines. And you can see one more link, the number of nines depend upon the number of digits which are repeating. So 3 digits are repeating, so 3 nines. Here, yes, 13 by 9, 9, and this digit was not repeating. So a 0 for that. Okay. Simple derivation. See, if I take x as 0.013 bar. So first of all, I'll multiply by 10x, 0.13 bar. Then this, so we can easily write as 13 over 99, right? Just now we derived that logic. And at the end, this divided by 10 will happen. So we'll have 990. Got it? So number of zeros will depend upon number of digits which are not repeating after decimal, of course. And number of nines will be same as number of digits which are repeating after decimal, of course. So simple 6 by 9, which is 2 by 3. Now in this case, now I'm directly giving you the shortcut. You can just derive like this and check. Okay. 5.3 bar. So ultimately the entire number is 53 without any problem. Yeah, forget decimal, forget recurring. Minus the non-repeating part. The non-repeating part is 5. Divide by. Only one digit repeated. So 1, 9. 53 minus 5. 48 divided by 9. 16 divided by 3. Correct? Yes. Entire number minus non-repeating part. So come on. Similarly in this one, I'm sure you must have done it. You can pause the video and do it. 1253 minus 1 divided by 999, right? Because 3 digits are repeating. 1252 divided by 999. Okay. Got it? Sure. All right. Now fractions. Fractions is nothing but a part of a whole. That is the theme based on which the fractions were invented. Yeah. So suppose you have a pizza with 8 slices and someone asks you for 2. So no problem, right? You can easily give it. But if someone asks you for 11 slices, something awkward, right? Yes. So 2 by 8 is therefore called as proper fraction, while 11 by 8 is improper. Simple emotions, simple logic. They're still fraction, but it is not behaving with the thought of this part of whole. So 11 by 8, you observe that numerator was bigger than denominator. So it is improper. So their value will be more than 1. And if the numerator is less than denominator, it is proper fraction. So value will be less than 1. All right. Yeah. So proper fraction is the one where the numerator is less than denominator. So value is less than 1. And in improper fraction, the one where is the numerator exceeds the denominator, the value is greater than 1. Understood? Yeah. Okay. Positive and negative. Come on. Positive into positive. Positive. Negative into negative. Negative. Positive. Negative into positive. Opposite signs. Negative. Positive plus positive. Positive. Negative plus negative will always give you negative result. Negative plus positive. Come on. Yes. Suppose minus 3 plus 2. So it is minus 1. But if I do minus 3 plus 5, it is 2. So it depends, right? Which type of numbers you are choosing. Chalo, this one, come on. I am sure you must have done it. Pause the video and do it, yeah? Then see this. So positive plus positive, positive. Positive minus negative. Positive minus negative means something like 4 minus minus 3. So ultimately addition. Na? So the result will always be positive. Got it? Dealing with positives and negatives. Yeah. Let's also see one more thought, friends. Comparison of fractions. Important, especially for DI and all. Yeah, where there is more of calculations and we need to compare which is highest, which is lowest, and all those things. There are some shortcuts. Let's see. Rule number one: when the difference in the numerator and denominator is same, for example, 4 by 7 versus 5 by 8, the gap is same, right? Similarly, 16 by 13 versus 20 by 17, gap is same, 3 only. First, check whether the fractions are proper or improper. If proper, the larger numbers will give you larger fractions. Remember, proper fractions behave properly. So the one which looks bigger is actually bigger. Okay. So here 5 by 8 will definitely be more than 4 by 7 for sure. Yes. And in case of improper fraction, it is reverse. You can remember like this: improper fractions behave improperly. So larger numbers will give you smaller values. Means 20 by 17 looks bigger, but actually its value will be smaller. So 16 by 13 will be bigger in this case. Yeah. So rule of thumb is proper fractions behave properly. Simple. Okay. All right. Now, when either numerator or denominator can be easily made equal, second rule, for example, this. Yeah. In this case, when the denominator is same, of course, larger the numerator, larger is the fraction and vice versa. So 15 by 21. So here we multiplied by 3. So it became 15 by 21. So this is 16 by 21. Forget 21. So 15 is less than 16, right? So first fraction is less than second fraction. Yeah. Now if you make the numerator same, smaller the denominator, larger is the fraction, right? So here I can make 12 and 18, both of them as same numbers. So which number? 36. So 36 divided by 21, 36 divided by 22. Of course, smaller the denominator, bigger the value. So fractions behave in the same way as numerator, but opposite to denominator. Means if the numerator is bigger, value is actually bigger. But if the denominator is bigger, value is smaller, that way. Okay. All right. Rule number 3. When neither rule number 1 nor rule number 2 works. Yeah. Let's see. Cross multiply. Then this will work. So 5 by 7, 8 by 11, cross multiply. So 5 into 11, 8 into 7. Actually, what are we doing? We try to make the denominators equal. Yeah, 7 into 11, 11 into 7. So denominator is the same. So you can forget the denominator. Just compare the numerators. So 55, 56. Correct? So 56 is bigger. So second fraction is bigger. Same. Here also, I made the denominators equal. Forget the denominators. So 19 nines are 171 and 13 13s are 169. So this is bigger, means first fraction is bigger. Yeah. Got it? Sure. Okay, let's try a few examples. Come on. Yes, gap is same. So rule number 1. Yeah, improper. The one which looks bigger will be smaller. Come on. In this case, I can do one thing. I can make the numerators equal. So here into 2 and here into 3, right? So into 2 here, into 3 here. This will be in 1500s. This will be in 1400s. Of course, smaller the denominator. The first fraction is bigger. Okay. Here rule number 2, right? I can make the numerators equal. So 14 into 3. So 42, 42. And now this is 363. The smaller denominator. Second fraction is bigger. Understood? Yes. One more. 453 divided by 462 versus 463 divided by 452. Are you even thinking about any rule? Don't think. Pure waste of time. This is proper fractions. Numerator is smaller than denominator. Be careful. Be open. Be alert. And here's reverse. So this is improper, more than 1. This is proper, less than 1. So of course, second one is bigger. Isn't it? That thought was getting checked here. Yes, how alert you are. Chalo, dealing with 0. So adding a 0, no change, right? Subtracting 0, no change. Multiplying by 0, yes, the value becomes 0. Dividing by 0, not defined, right? Great. Chalo. Subdividing natural numbers now. Further types of natural numbers. even and odd, and then we have prime, composite, and one. Yeah, let's first see even odd logic. So basically, the numbers which are evenly divisible by 2 are said to be even. For example, 2, 4, 6, 8, and so on, right? The numbers which when divided by 2 leaves a remainder of 1. They are odd numbers. So 1, 3, 5, 7, and so on. Yeah. So the definition is normally applied to natural numbers, but it can be extended to integers. Okay. So these are even integers. They are odd integers. So basically, when integers divisible by 2, they can be called as even integers, and integers not divisible by 2 are odd integers. So when I say integers, entire number line is open. Negative, positive, 0, everything. Otherwise, it is by default type of natural numbers. Okay. Chalo, behavior, again, very important logical point. So even plus even, yes, even. Odd plus odd, you can simply take any number and check it. Yes, even. Odd plus even, of course, odd. So odd number of odds will always give the sum as odd. Chalo. Even into even, even. Even into odd, odd. Odd into even, even. So even one even number will give the product as even. So in the product, even if one number is even, the product will be even. All right. Yeah. Sure. Okay. Next ones are prime and composite. Okay. Prime and composite. So all the numbers can be created from 1 by addition. Okay. For example, 2 is like 1 plus 1, 3 is 1 plus 1 plus 1, 4 is like this, 5 is like this, 6 is like this, 7 like this, and so on. But some can never be created from others by multiplication. For example, see, 4 could be created 2 into 2, 6 2 into 3. Yeah. So they are composite numbers. But these numbers, they cannot be created from other numbers by multiplication. So they are the prime ones. Okay. So primes are the most basic and important numbers in the number theory. Correct? Okay. Now, first few prime numbers, if I tell you first few prime numbers, actually from 1 to 100, you should know all the prime numbers. Yeah. There are 25 prime numbers which you should know properly from 1 to 100. So first few prime numbers 2, 3, 5, 7, 11, 13, 17, 19, and so on, 23, 29. There are 25 such prime numbers from 1 to 100. Okay, remember this. Yes. But do you know how do we check whether a given number is prime or not? Yeah, let's see. Smaller numbers you can easily check. I know you divide by 2, divide by 3, and so on. Yes, you'll try with few numbers and then you will give up. If it is not divisible, then you will say, yeah, it is prime. What if it is divisible by some bigger number then? So let's learn how do we check whether a given number is prime or not. For example, 301. So will we divide n by every number less than n? Means I'll divide 301 by every number up to 300 starting from 1? No, right? Will it be every prime number less than n? No, we have even better logic. Yes. Now see, every prime number but less than square root of n. There you are. Okay. Great. So for 301, we will just check for nearest perfect square is what? 17 is 289. 18 is 324. So up to 17. So from 2 to 17, list down all the prime numbers only. For example, 2, 3, 5, 7, 11, 13, 17. Check with these only. So it turns out to be divisible by 7, friends. 301 is divisible by 7. So it's not a prime number. That is, apart from 1 and 301, there is one more factor. 7. So basically, prime numbers are the numbers which can be which are divisible by only two numbers, 1 and itself. That is, they can be created by multiplication by of 1 and itself, no other number. Okay, they are prime numbers. So 301 is not a prime. This is how you check a prime number. And composite numbers are those numbers which are having more than two factors means they're divisible by more than two numbers. So they'll have minimum three divisors or three factors. Okay. So by that logic, 4 is the smallest composite number. 2 is the smallest prime number. So 2 is satisfying this definition of prime number, that it is divisible by 1 and 2. That's it. 1 could not satisfy any of these two definitions. So we can say that 1 is neither prime nor composite. Okay. All right. So remember these few basic things. Yes, friends. Okay. So friends, identify. Yes, it's composite, right? Correct. Prime, prime, composite. Yes, composite. 1. No factor except 1. So neither prime nor composite, and 2 is the smallest prime number and the only even prime number. Okay. Got it? All right. In case of even odd, friends, if you take raised to format, suppose a raised to b format, here if a is odd, odd raised to odd, yes, it will be odd, right? Odd raised to even, again odd only. Even number raised to odd number, even. Even number raised to even will be even. This will be the result. So we can say that the value of the type of value of a raised to b depends upon the base a, as long as the power is not 0, right? Because if the power is 0, we know the result is standard, that is 1 only. So if the base is odd, you saw that result is odd only. If the base is even, you saw that the result is even. Okay, cool. Till now, what all we studied? We studied the entire number tree, correct? Then converting recurring into fraction, then even odd operations. Okay, so this much we have done basically. Then one more type is relatively prime numbers. Yes, simple definition, the two numbers that do not have any factor common other than 1. For example, let's check these two numbers. So I have listed down the factors of 10. Similarly, factors of 15. Can you see the common factors? There are two common factors, 1 and 5. So they are not co-prime. Okay. But check this out, 13 and 20. So we have listed down the factors. Now what? The common factor is only 1. And this is the definition. So it satisfies the definition. So 13 and 20 are co-primes. So first of all, relatively prime number. But did you understand? Two numbers only can be called as either co-prime or relatively prime. A single number is not relatively prime or co-prime. There should be two numbers. Okay, please note this. Chalo, Amal, if you really understood, think about this. For the two numbers to be co-prime, at least one of them should be prime. True? Not necessary, right? It's false. Simple. 21, 55. None of them are prime, but still they are co-prime. Check the common factors. There's only one common factor, that is 1. So they are co-prime. Yes. Now, two consecutive numbers will always be co-prime. You know, friends, take any two consecutive natural numbers. You will see that one is odd, other is even, and nothing will be common between them except 1. 1 तो सबका ही factor है ना, तो 1 तो common होगा ही, तो 1 पे किसी अकेले का हक नहीं है. Okay, so 1 has to be common, but it should be that only 1 is common, nothing else. 1 is co-prime with every other number. So if you take 1 and 6 co-prime, 1 and 10 co-prime, 1 and 9 co-prime, 1 and 23 co-prime, because 1 का कोई factor ही नहीं है. There is no question of being common, right? Great. Okay. All right. So that is it, friends. This much is the bare minimum basics required in case of numbers, all the types of numbers. Yeah. So this is the session 1, topic 1, wherein we discussed all these things. Which things? The classification, converging from recurring to fraction. Yeah. So one more thing. Let me just repeat it. The number tree and the conversion point. So number tree, come on, quickly draw it. Complex number. Yes. real and imaginary. Imaginary was that I containing I is root of -1, right? Then we saw that I cycle, the 4 powers. The real numbers, 2 parts, rational, irrational. Rational was P by Q form. That is, decimal part should be either recurring or terminating. Both these are the features of any number to be a rational number. We can convert that into P by Q form. And if you can't do it, it is irrational. Q complement, Q raised to C, non-recurring and non-terminating decimal. Example like surds and pi. In rational, 2 types, integers and fractions, friends. Integers means 3 magical words, numbers without decimal, right? And we have negative and whole numbers. Whole numbers will be 0 and positive, that is natural numbers. Cool. In fraction, we have 3 varieties, proper, improper, and mixed. Proper means value is less than 1, improper is value is more than 1, mixed means something of this format. That is addition of an integer and a proper fraction. Okay. Then natural numbers, further classification, even, odd, prime, composite. Great. All right. Then we saw relatively prime numbers. Yeah. All right. When I say even or integer, odd integer, I hope you understand that integers that are divisible by 2 are not divisible by 2 accordingly. Okay. In prime number, we saw what is prime number, the definition, the property, how to check a prime number. One more thing I would like to tell you about prime number, some unique property of prime number. You know, any prime number more than 3 can always be written in the form of 6k plus or minus 1. K is some natural number. So you can take any prime number, suppose it is 97. So I can write it as 6 into 16 plus 1. You know that 97 is a prime number. 89 is a prime number. 15 into 6, 6k minus 1. Sorry. So if it is a prime number more than 3, you can always write that prime number in this particular format. But please note, be careful, the reverse is not true here. For example, 25 is a number which is satisfying this pattern, friends. 6 into 4 plus 1. Pattern got satisfied. But is 25 a prime number? No. So please understand, if it is a prime number, you already know. So you can write that in the format of 6k plus 1 or 6k minus 1, where k is a natural number. But any random number which is satisfying this pattern need not be prime. Yeah, otherwise this would have become a nice test to check a prime number. हम उतना लंबा क्यों करते हो? ठीक है? Cool. Now, then suppose if it is a recurring number like this, A, B, C, D, E, F, G, H, just an example, I'm giving you a format. So numerator is entire number without any decimal or recurring part minus the non-repeating part, which is A, B, C, D here, and divide by how many digits are recurring or repeating? 4. So 4 times 9 in this example, and 2 are not repeating, so 2 zeros. Okay. This is a common pattern, shortcut of converting a recurring into fractions. I hope you're comfortable with even odd operations. Okay. This is the thing which we studied in this video. I hope you understood. All right. Thank you so much. So take care, stay safe, stay focused. Thank you so much for devoting your time to watch this video. I hope you have taken the notes, everything. Yeah. So see you in class where we'll solve more and more sums. Thank you so much. Take care. Bye-bye.